Hello all together. My name is Thilo Bein. I'm welcoming you into this first afternoon session on the green vehicles next generation electric drivetrains. My name is Thilo Bein. I'm moderating the session. I'm with Fraunhofer LBF. The session will go on that Michael will briefly introduce the overall picture of the next generation electric drivetrains. Afterwards, we will have 3 presentations. I will briefly introduce the speaker and then start the video presentation. Meanwhile, you can ask questions via the chat function. To the left of your screen, you should have the chat function. You can phrase question there. And I will collect these questions, and at the end of the 3 presentation, we will have a Q&A session where all the 3 speakers are online and can answer your questions directly. I will moderate the session. I will pass the question to the presenters, and then they will answer. For the time being, I will pass the word now to Michael for setting the scene. Michael?
Well, thank you very much, Thilo. So, good afternoon, ladies and gentlemen. So my name is Michal Klima. I'm from the Innovation and Networks Executive Agency, and I would like to as well welcome you to this green vehicle session dedicated to 3 projects. So Drive Mode, Module ED, and Free Drive. All of them are funded from the GV topic for 2017, the next generation electric drivetrains for fully electrified vehicles. The main objective of the Green Vehicle Call is the use of new types of non-conventional energies, such as electricity, in order to improve road transport performance with respect to CO2 and other relevant transport emissions. Therefore, in order to support a massive introduction of electrified vehicles, the particular objectives of the topic next generation electric drivetrains were to, for example, improve functional system integration of electric machines, then reduction of the need for rare earth magnets for electric machines, design that is optimized for lower cost of manufacturing, and then, for example, introduction of modular electric powertrain components. As the results from this project, the main expected impacts are reduction of cost for electric motors and for power electronics. And then in terms of electric motor performance, we expect to have increase in specific torque and specific power of electric motors. We are expecting increase of maximum operating speed, and we are expecting as well reduction of motor losses. In terms of the performance of the power electronics, it is expected to increase the power density and as well the reduction of losses. This is a very interesting topic, and the expected impacts from these actions will be demonstrated on full-size working prototypes. For all 3 projects in here, this is scheduled for spring 2021, when hopefully we will all have the opportunity to see the vehicles with integrated components which are resulting from these 3 projects. For more details concerning these projects, please stay with us in this session. And as this is a short introduction, thank you very much for your attention. And now, Thilo, floor is yours again. Thank you.
Okay, thanks a lot, Michael, for this good introduction. As said, we will have 3 projects presented here in the session. The first project is Modular ED. Yeah, thank you very much, Alicia, for this nice presentation. I would like to ask now all speakers to go online, turn on your microphone and your camera. We are now starting the Q&A session. I hope that Alicia managed to get online. If not, you still have the chance to phrase the question in the chat, and I'm to answer your question directly into the chat. Let me first introduce once again the different speakers. We have started with Charlie Laneluk from CEA presenting the module ED project, which was addressing a modular powertrain concept. Then we had Miko Pilati from VTT. He is a coordinator of the DriveMove project, developing a very high efficient drivetrain concept. And then finally, we had Alicia Rodriguez from CDOUT presenting the ReFree Drive project with the rare earth free drivetrain with much better performance. Let me start first with Charlie. There was one question about the advantages of gallium nitride with respect to silicium carbide for the power inverter in terms of performance and costs.
Yes, I can see the question. So the question is, which are the GaN advantages with respect to SiC for power inverter, and how about gallium raw material accessibility?
Yes.
So I would say first that gallium nitride semiconductor has low switching losses and conduction losses and no recovery losses. So it will make the inverter more efficient. For sure, SiC is very, very efficient and is very efficient technology. But the advantage of GaN, it has no recovery losses for the body diode. And I would say that GaN is CMOS compatible, and so it can be manufactured by all standard equipments. SiC is not. So this is why gallium nitride will reach normally the price of silicon die in the future, whereas SiC will not, because it uses very energy consuming steps for the manufacturer. So normally, at the end, the inverter with gallium nitride in the future will be at lower cost and efficient.
Okay, thank you very much.
I forget an answer about how about gallium raw material accessibility. Yeah, it's a good question. I think, if I remember well, that gallium is extracted from bauxite, and bauxite is widespread in the world, in America, Australia, Africa. If I remember, you can go on the internet, but a few of industrials are extracting the gallium from the bauxite. I think it's 1 or 2% of the overall bauxite extraction, so it's not so much.
Good. Thank you very much, Charlie. So the next question goes to Miko. There was one in the chat about the improvement you expect when using 3 gears instead of 2 or even 1 gear in your motor design.
Yes, thank you. I think it was Maurizio placed the question. We did have a full design cycle for the transmission, including, well, basically starting from the design speed of the vehicle and the gear ratios and the speed of the motor. I cannot give you direct answer on the different options. We did study the 2-stage, 3-stage, optimizing that with regard to the design point and the driving cycle of the vehicle. But I cannot place a number here from my by heart on which were the efficiencies and the dependencies on that. I think it will play in the end a role of as to the design point, that the vehicle and the powertrain, for example, if you have high speed car, low speed, if we design it for urban traffic, for example, with lower maximum speeds, and depending on that total design, then end up with the gear ratio or then the stages of the transmission. But yeah, we can get, if you want more detail, we can get back to the details of the design separate and later.
Okay, thank you very much, Miko. And then there's also a question to Alicia. Alicia, can you hear us? For now, it seems to be frozen. No, at least I can't hear her. Then let's continue with the question in the chat, once again for Charlie on module ED. And there's a question, why does the e-axle have a metal sheet housing instead of usual casted one? Are there any particular advantages why you choose the metal sheet housing?
Good question. We choose the metal sheet especially for the shielding for power electronics. So it is about electromagnetic interferences, and we have to shield our electronics to not be disturbed by fast switching of GaN devices, much faster than silicon devices. So this is why on one hand we use it as a chassis, but I would say we also use it because it is more robust and reliable. But I can ask my mechanical partners to have more answer about that. I think I am not able to give any more answers about this topic.
Yeah. Okay. Thanks a lot, Charlie. Then there's another question from Miko. From my side, you reported a very high efficiency at maximum power in your motor design. I assume that you also could validate this high efficiency in the measurements, but how did you achieve this high efficiency?
Now, of course, I don't have the actual designers of the machine here online, but basically there was a lot of design iterations by University of Ljubljana and AVL working together on optimizing the permanent magnet machine. I cannot in this occasion here go to the electromagnetic details of that solution.
Okay, then we should go directly to the project partners. There's one question to all of the project from Ellen Buscairol. If there's any issue with electromagnetic interference with the WPG converters so closely integrated to the machine and the sensors. Maybe Miko, you can start, and then we continue with Charlie. And Alicia, if you could phrase your answer in the chat, that would be quite helpful.
At least we have not identified anything related to that yet. Of course, we did not specifically address that in the design phase. That it's of course possible. We are having compact installation with the different components very close to each other, so that might be an issue. So far we didn't observe any specific things related to that.
Okay, thanks. Charlie?
On our side in Module D, we have noticed electromagnetic interferences, and so in such application, when you are using wide bandgap semiconductors with high DVDT, high DIDT, and with fast switching, you must have a good chassis. It's like a bin for parasitic currents, which does not contribute to the good operation of your converter. And also, you have to integrate your inverter using wide bandgap technology close to the motor to avoid reflection on the windings. Otherwise, you can destroy the insulation of the motor. So this is why you have to integrate it as close as possible of the coils. And I think it's all I can say. But yeah, it's for sure EMI are a very good. It's a very good question. Sorry, and we have had some problems on it, and so you have to be careful when designing such a converter in high power.
And there, I think there is another issue related to the, let's say, high degree of integration, which is, you, Charlie, indicated it, is the reliability aspects. Did you already, for both or three, did you already make experience related to the reliability, and how did you assess or evaluate the reliability of your particular design? Maybe Charlie, and then we go back to Miko.
It's a compact design, taking into account all the the issues that we can have with wideband gap. And so far we are a research institute, so concerning the reliability, we do not have made all the tests that like an industrial. So it's at a certain point we can say that the inverter made is reliable enough to be integrated in a test bench, but not in an electric vehicle. But there are more issues about big good integration. It's also about thermal management. So when you have little things to be integrated in close to the motor, you have to take into account the thermal management because you have smaller system and you have to extract heat of it. We say that it is efficient, okay, but you have losses. But little it is, and more difficult is the thermal management. So I think thermal management, we did not discuss about this, but it's a very complicated issue.
Yeah, but you will have superimposed loadings. It's not the thermal and electrical loading, but you also have the mechanical loading.
Yeah.
Are you considering those as well?
Oh, okay. Okay.
It's a difficult question. Let's continue with Nico and let's see how he's answering that one.
Yeah, thank you.
Sorry.
Yeah. So if I take the next one, of course, it's an extremely relevant question. Moving from now, we are dealing with the research and innovation project, and we are of course at the not at the commercial level, and we cannot either run like long duration tests really to observe some temporal development or changes in certain components. What I can say that we did encounter some things in the IDM, some of the IDMs, some components broke. We are in the process of corrective actions on those, which is just indicating that we are really not dealing with the product as such, but it's more like a research thing, and longer term tests would be of course needed to really to take a full understanding of the reliability, endurance, durability, and such things. But for sure that is included in the analysis, and of course the management, thermal management, combining all the mechanical, electrical, electromagnetic, and the impacts, and that will be part of the assessment of the IDM as a whole when we continue and complete the testing sequences to kind of assess where on technology readiness scale where we are, and how that would then maybe transferred to a real product development process if it were continued.
Okay, thank you very much, Mikko. I checked with the chat. There are no further questions, so we scheduled about 10 minutes for the Q&A session. We are a little bit longer now, so I would like to propose to close this session. I particularly would like to congratulate all the three coordinators and the whole consortium of each of the project for this nice achievement. It is very promising. You showed quite good results, and I'm really looking forward to the final reports from your three projects. And I would like to thank all three of you for taking your time to present the project and being available for the Q&A session. By this, I would like to close this session. We were about between 55 to 60 participants, which is quite nice in the afternoon session right after lunch. I also would like to thank the participants for the questions and for staying the whole time here with us. Thank you very much and have a nice afternoon.
Thank you very much.
Thank you. Thank you very much. Bye-bye.
Bye.